Hi guys, and welcome to Physical Sciences for Year 10. In this video we're going to be looking at the concepts of speed and velocity. Now speed and velocity you'd think are the same things, but speed is what we call a scalar product and velocity is what we call a vector. Now speed is basically made up of two components, that is the distance and the time, and that can be calculated using the formula in inverted commas v equals s over t, where s is the distance in meters and t is the time in seconds. Another useful tool that we can use with this equation is the triangle that you can see on the right hand side. This allows us to determine unknown quantities. So for example, if I wanted to calculate the speed, I cover up the v and write down what I'm left with. In this case, if I cover up the v, I've got s at the top, followed by a line, followed by a t, which means distance over time, so there's the formula. If I wanted to find the t and I'm being given the distance and the velocity, I cover up the t, and to calculate t would be distance over velocity. Likewise, if I wanted to find the distance and I've been given the speed and the time, I cover up the s and I write down what I'm left with, s equals v times t. So the triangle is a really useful tool for rearranging the formula v equals d over t, s over t. Now, you'll be given this formula, v equals s over t, at the front of your exam paper, not the triangle, so you'll have to learn that. Now, velocity, or speed, is measured in meters per second. Now, that can be noted as m/s, or ms to the negative 1. They both mean the same thing, but you just need to be able to understand what they stand for. Because in a question, you may have m/s, or you may have ms to the negative 1. Either one can be used after the speed, that's fine. You just have to be able to recognize it. Now, as I said, speed is a scalar product, but velocity is a vector. This means that it has a size and also a direction. Now, at this level, we will not be covering the direction part of velocity. That will happen in year 11 and 12. But I just wanted you to be aware that velocity is a vector, and as a result, it does have a unit of direction linked with it. But all your questions in this video and in this unit will all be on a scalar version. Okay, so in order to calculate velocity, as I said earlier, we have distance, which is measured in meters, and time, which is measured in seconds. We must make sure that we convert our distances and our times to the appropriate units. So if you go to exercise 1.4 on chapter 3 of the iBook, you will see a few exercises which will allow you to convert distance from kilometers into meters and time from minutes or hours or days into seconds. So have a go at that now and then come back and have a look at the examples that we're going to run through in a second here. Okay, so the first example using speed we've got here. Miranda travelled 60 kilometres from Pakenham to Melbourne. It took her an hour to make the journey, and we've got to calculate what her average speed is in meters per second. So the first thing I get my students to do is to write down what do we know. Well, we know the distance, which is 60 kilometres, the time, which is an hour. We've got to calculate v, and we're going to use the formula v equals s over t. So that's fairly straightforward. Now you will notice that the distance is in kilometres and the time is in hours, but we want it in meters per second. So we have to do a conversion. So the second point is to check your units, make sure that they're in the appropriate form so that we can do our calculation. So to convert distance into meters, we've got kilometres. You'll have already done the conversion from the iBook. It's 60 times 1,000, so it's 60,000 meters. To convert an hour into seconds, we know that there are 60 minutes in an hour. Multiply it by the number of seconds in a minute, and we get 3,600 seconds. So in 1 hour, I've got 3,600 seconds. So I've got all my variables in the correct units, meters and seconds. So now I can do my calculation. So I substitute these into v equals s over t, which means I get 60,000 divided by 3,600, which gives me 16.7 meters per second. Now, if you follow this process through for every example, you can't go wrong. You've got your formula, you just need to do a few checks, because in your exam, you're going to be tricked into using different things to make sure that you understand what's going on. So don't fall into that trap. So let's look at example 2. In this case, Sally took 2 hours to travel from her hometown to her uncle's farm, and she was travelling at a speed of 90 kilometres per hour. We've been asked to work out how far she travelled in kilometres and metres. So let's write down what we know. We know her time was 2 hours, and we know that she was travelling at a speed of 90 kilometres per hour, and we've got to find S. So in order to find S, use the triangle. Cover the S, and that will give you the formula to calculate S, which is V times T. So now let's do our conversions, where we know we've got hours and kilometres per hour. So to convert kilometres per hour to metres per second, I have to convert the kilometres into metres and then the hours into seconds. So I know there's 1,000 kilometres, there's 1,000 metres in a kilometre, and I've got 90 of them. So that's 90 times 1,000, and I know there's 3,600 seconds in an hour. So it'd be 90 times 1,000 divided by 3,600 gives me 25 metres per second. Now I've got to do the same with the time. The time is in hours, and I need to convert that into seconds. Well, we know there's 3,600 seconds in an hour, and I've got 2 of them, so obviously the time it took her was 7,200 seconds. So now I've got my velocity in meters per second, and I've got my time in seconds. So now what I need to do is to do the calculation. So the calculation is S equals V times T, so it's 25 times 7,200 gives me 180,000 meters, or if I divide by 1,000 I can convert it into kilometers, which is 180 kilometers. So you can see that by knowing your conversions, it's very easy to use the formula and find our unknowns. Okay, let's have a go at a third example. In this case, Rosie travelled 250 kilometers at an average speed of 85 kilometers per hour, and we've been asked to work out how long it took her in hours and seconds. Okay, so let's write down what we know. So she travelled 250 kilometres. She's travelling at a speed of 85 kilometres per hour, and we've got to find T. So cover up the T, and what are we left with? It's S over V, or distance over velocity. So the next thing we need to do, we notice that everything's in kilometres and hours, so we've got to convert into metres per second. So we do our conversion. The distance basically is 250 kilometres. We know there's 1,000 metres in a kilometre, so it's 250 times 1,000, which is 250,000 metres. We know that 85 kilometres is 85,000 metres, and we know that there is 3,600 seconds in an hour. So we do 85 times 1,000 divided by 3,600. So I end up with 23.6 metres per second. So as you can see at the bottom, it says in this case we could use the figures as is. Well, that's fine because everything's going to be in hours, and then we can convert into seconds at the end. So it's entirely up to you how you do it. So we're going to use this formula because it's useful using the conversions. So we can go on and do our calculation. So our calculation here is T equals S over V. So I know that my distance travelled was 75,000 metres, and she did that at a speed of 23.6 metres per second. Now that comes out at 10,588.2 seconds, or 2.9 hours, but 0.9 of an hour is 59 minutes. So it's 2 hours and 59 minutes. Okay, so I hope you feel comfortable using those 3 examples. The idea of those 3 examples is really to get you to do your conversions and then do some manipulation. If you also look at some of the calculations that we've got in the iBook, and if you have a go at the problems that are on the iTunes U course, you'll cover all the different types of questions that you could get in an exam. So I'd like you to have a go at exercise 1.5 in chapter 3 from the iBook, but also have a look at the speed problems which I put on the iTunes U course. Okay, thank you for watching.